we go. All right, 1.3c, properties of functions, graph maxima and minima. Okay, maximum and minimum are the plural words for minimum and maximum of a graph. Okay, you don't say maximums and you don't say minimums. Okay, the plural is maxima and minima. Cool. Kind of like syllabus, you say syllabi. It's one of those weird ones. Or cacti, yes. All right, your local minima means that at some point, as you can see here, you are decreasing, then increasing. Generally, your local maximum means that you increase and then you decrease. Okay, so that's the first thing we're gonna do is locating it from a graph. So you should have this on your notes, right? No, fill in the blanks where it's bolded. Yeah, do we? Yes. All right, the local maximum. So if you look at this graph, notice here our local maximum from left to right, we are doing what? Increasing, and then we are decreasing. So notice that it's an increase and decrease. So in the blanks, you're writing a local maximum at C, if there's an open interval, L located containing C, so that for all X is not equal to C, this is going to be true. Okay. And we call f of C a local maximum. So you should have the blanks. You have the blanks? Only blanks. Oh, then they're not leaving blanks? It says local minimum, local maximum is. Oh, yeah, just do the top one. This is the formal definition that you don't need, as long as you understand this. And it occurs here. Okay. So what I do need you to do is to the side, draw the curve. So you're drawing the curve, showing that you are curve concave down is a sign of a maximum. Okay, and the keyword local means that you can have more than one. So we increase and then we decrease. Okay, anyone want to take a stab at what happens with a local minimum? The lowest point. The lowest point. So the local minimum is f of C, and that's because we decrease and then we do what? We increase. Yeah, isn't that the same thing? Yes, but it's local minimum and you got to draw the picture along with it. Okay. You got to draw your picture. Yes. So this is the second picture you're drawing. You can move to it. There's a seat in the front. You can show move. All right. So when you're looking at this, the value of f of x, so a point to the right of f of c is going to be greater because that's back when it starts to increase. All right. Now we're going to put into practice. So you should have this graph. Yes. This is the graph that we're going to be analyzing for the next, I don't know how many examples. 5, 4, 5. All right, so it says at what numbers, if any, does f have a local maximum? Okay, remember x marks the spot. Everything is defined by our x, right? So when I'm looking here, I'm going to go through and mark where I'm increasing and where I'm decreasing. So this is a decrease, this is an increase, this is a decrease, and this is an increase. Based on the definition, to have a local maximum, that means that I have to increase, then decrease. At what point do I increase, then decrease? Here, right? Yeah. At x equals 1. Do we see that? And remember, x marks the spot, so we're just saying where it's at. How do you feel about finding that? So it goes a single number, not an ordered pair? It's a single number. That's why it just says what number. Yeah. Okay. You just write x equal. Y is the value. So if I ask you for the value of your maximum, then you would tell me y equals 2. Where it's located is your x. Okay. So key thing to remember, where you're looking for your x, what you're looking for your y. So think about a treasure map. X marks the spot. Why are you going there? What are you looking for? The treasure, right? All right. Now we're going to still use that same graph. And we're going to do I forgot I had wrote it out for myself. Let's try that. Okay, so now we're gonna do the local maximum. Now, what did I tell you what meant? Y. So what are the local maximum? What is it? It's 2. Okay, where we're going is going to be our X. What is going to be our Y? So our local maximum is 2.
Why isn't it y equals 2?
You can write Y equals 2 or just write maximum value. This is the formal way of writing it.
But y equals 2 is so good.
But you just gotta be comfortable with reading it in a sentence.
Is there a shorter way to write maximum?
Write the 7 letters. The plural of maximum is maxima. What'd you say?
Well, she's saying why aren't there?
This is saying at what number I'm doing it. So like, where does it happen? At what is another way of saying where, right? At where do you want me to meet you? You know, at what, you know.
And then
What is it is your Y. What is the Y value there? Okay. The where is your X. The what is your Y. Okay. We're going to do it again, but this time we're going to do the minimum. So looking at our graph, we had already marked it as decrease, increase, decrease, and increase. What makes something a minimum? It's going to be a decrease, then an increase. At how many points do I decrease, then increase? I decrease at 2 points, right? And those 2 points are at -1 and at +3. Agreed? That's where it happens. And because I'm looking for where it happens, that's the what again? The where is the X, where it happens. Okay. What is my local minimum? What are the local minimum? What are they? They are 1 and not 2. 0, 1 and 0. Okay, because it's the Y value of where it's at, right? So this one is at -1, 1. Oh, it's written there. My bad. This one's at 3, 0. Yes. Okay, where's what again? Tell your neighbor where's where. Where means I'm looking for the what? And tell your neighbor the what means I'm looking for the. Okay. All right, now we're gonna talk about, oh, poopers, that wasn't supposed to pop up.
Oh, I got it. I thought that said -3.
Okay, this was supposed to like pop up as I clicked, but it did not, so we're gonna roll with it. Guys, your intervals. So we've already marked this as a decrease, as an increase, as a decrease, and as an increase, right? Now we're gonna write it out. So how did I know? Where was this increasing at? Well, it increased from -1 until +1. Do we see that? And then we increased from 3 to, and we're going on forever, so to infinity. Okay, this is why these are my intervals of increase.
we always just with X.
And we always use X and we always use parentheses. Remember we talked about that the other day? We only use parentheses and we always use X. Okay, now we're gonna look for our interval of decrease. So we're looking for decreasing. We've already marked them, right? From left to right, where do we start to the left? What's furthest to the left called? Negative infinity. So we start at negative infinity, and what stops us? -1. So that's why our first interval is from negative infinity to -1. Our second interval that we marked, we start at where? At 1, and we end where? At 3. Okay, so those are our intervals of increasing and decreasing. Those intervals are important for us to identify where our maxima and our minima are. What are your questions? If you were given a graph and you had to find local maxima, local minima, intervals of increase and decrease, could you do it? Yes? If not, ask me a question. If you said no, or you're like, what would be what stop you? Gerardo?
What was the question?
What would stop you from being able to do this problem completely on your own?
Completely on your own. If we didn't have the graph.
Okay. You'd have the graph. What would stop you if you had the graph for finding what we just did?
Nothing.
Okay. All right. Remember, I'm getting the green light, so we're going. Is this facts?
Yeah.
All right, so we're moving on. Our next objective is to use a graph to locate the absolute maxima and the absolute minimum. We're gonna absolute, the word changed. So we had our local, and now we're at absolute, okay? A little bit of different in what we're doing, okay? Your absolute means it is the highest or the lowest, okay? So you're no longer listing them all out. You're only listing out the highest and the lowest. Does that make sense? Yeah? Because it's your absolute. All right. When I say something, what's my absolute favorite thing? I'm going to only list out one thing, right? Same thing here. Okay. Huh? Sure. All right. So let's look here. So we have this function. I was like, what is this called? This function. And we're looking at it. And we're going to identify our intervals of increase and decrease. So this is from left to right, we have a, then we have a, and then we have another increase, right? Yes? All right, so from here, it wants to know what is our absolute maximum. Our absolute maximum is at 3, and we write it as x equals 3. Does that make sense? Because that's our highest point. Okay, our absolute minimum would be what?
Oh, wait, 1.
It would be not 1, it would be 0, because it's the x that we're looking for, right? I'm glad you asked. Okay, and by the definition of a maximum minimum, you need to have a decrease, right? And then an increase. Okay, this could potentially have it, but this is a function that cuts off. And because we don't know what is happening, this still counts as a minimum. Just the same, if it was up here and it was the highest, it would count as a maximum because the function in theory could continue in some sense, right? But based on what we have, that's why I said it's your absolute lowest and your absolute highest, regardless of where you're at. Does that make sense? Okay. How do you feel about absolute maximum and minimum? Okay. All right, let's try it again. What is the absolute maximum here? Good. Absolute minimum here. So, like Ethan said, it is not 3. There is no absolute minimum because there's a hole there. Do you see how there's a hole? There's a hole in my graph right there. Okay.
Wait, why is when the whole mean?
The hole means that there's no value there. There's a gap in the function. It's called a discontinuity. It's something that breaks your function up. And we will learn more about that when we get to rationals.
So how does
We will learn how holes come into play. Is right now you're just analyzing it. Yes.
how does an order pair get a hole?
A rational function, which I just said we will learn more about in our rational unit. Right now, we're just analyzing the graph and we see that there's a hole, so there's no value there. Okay, so in this function, x cannot equal 3, even though it's the lowest point, there is no absolute minimum because there's no value there. Okay, let's try another one. What is my absolute maximum? Good job. What is my absolute minimum? Okay, now notice how I wrote it as an interval. That's because it's 1 all the way across. It is 1 from 1 to 2. And I can't list out every number between 1 and 2, can I? So I will not say that x equals just 1. I would say x is from 1 to 2. And I use brackets because it includes all those points. Okay, so this is an example when it's all more than 1 in a row, you use an interval to represent that. Does that make sense?
No.
So here we have to use a interval. Okay, so again, when is that x equals 5? What is 4? When is from 1 to 2? What is 1? We see it? This is when it happens. This is what it makes. This is when it happens. This is what it makes. Yeah? It depends on what it's asking. So I wrote it in a sentence completely so that you understand that they go together. But at any point, have we written it as an ordered pair? No, we have not. When we're talking about our maximum and our minimum, we do not write it as an ordered pair. We identified the part that it is, okay? Whether it's the where or the what. All right. Last one? Okay. 2 more? Okay. I made this last night at 1 a.m. Here we go. I can't. I stayed upgrading all y'all's quizzes and then I made finish your notes for today.
That just means you have to make it.
You're welcome. Example 5D. Here we go. What is my absolute maximum?
Positive infinity.
None.
None. There isn't one because it goes on forever. It's increasing forever, so there isn't one. What is my minimum? 0. There is a minimum of 0 at x equals 0. As long as you know what and where mean. So as long as you know what I'm asking for, then you write what you need to write in your notes. Okay? Where is at x? What is the value? What is at x? 0. Okay? All right. Absolute max.
None.
It would be none. Okay? It's because there's this asymptote that it's going, right? It's still going on forever, even though there's an asymptote. What about the minimum?
None.
Why is there not one? There's a hole. There's no absolute minimum, and that's because of our handy dandy. There's a hole in my graph.
You're gonna say it every time it's done?
I do. I do.
Okay.
Does anyone know where it comes from?
Everyone does it?
Just making sure. So y'all don't think I'm crazy.
That's a what?
Nowhere.
Say it again.
There's a hole in my graph.
Oh, my boot.
There's a snake in my boot. Toy Story? Toy Story with the button there? With the button? Okay, continuing. All right, this is extreme value theorem. So the extreme value theorem, it says if f is a continuous function whose domain is closed on the interval a to b, then f has an absolute maximum and an absolute minimum. So basically saying if your function has a starting and a stopping, it has to have an absolute maximum and minimum. Does that make sense? Okay. To prove this, you will prove it when you get to calculus. That's why this little asterisk here, it says it requires calculus. So you'll do more there with it. This is what we cover. And we're done. All right, our next objective is using graphing utility, aka a handheld device, a calculator, to find the maximum and minimum of a graph. Okay, that's where we're at. We're on the calculator part. No, handheld. You heard me. You heard me. I told y'all I did last year. I said we're not this year. Let it go. LIG, bro. Let it go.
Are we, it's gonna be on our own. Oh.
All right. Yes. A straight line, its maximum and minimum are the same. It's equal. Yeah.
How would you graph it?
So depending on where it started and where it stopped. So here we go. We're going to graph 2x cubed minus 3x plus 1. And we're going to look at it from -2 to 2. So I'm going to get my old school of faithful. And you have your new school. Okay. Notice that my RAM is what? Cleared. I've cleared of everyone's mess. How do I clear it again? There we go. Second plus 712. Second plus 712. Okay. Second plus 712 is how you clear your calculator. Plus 712. Second plus 712. Maybe if you're not gonna remember it. All right, so we're gonna go to y equals. We're gonna go to y equals to graph. So I'm gonna input my function. Yes, yes. We're putting in 2x cubed minus 3x plus 1. 2x to the power of 3. That is not a 2. And y'all were just gonna let me write it. 2x cubed minus 3x plus 1. That's all I've done so far. Don't yell at me. All I've done is put in the y equals. Yeah. Okay. Okay. All right. Now it gave us a domain. We're going to change our domain using the window button. So we're going to have to go to window and change our domain. We now have a minimum x and a maximum x to look at. Do we see that? So here's my x min and here's my x max. According to the extreme value theorem, is that on this interval, I should be able to locate a maximum or a minimum. Does that make sense? Yes. You have to use minus when it's appropriate and negative when it's appropriate. Okay, so I'm going to go to window and I'm changing my x min to what? -2 and my x max to 2. And I'm going to count by a half just so that it's smaller. I press window. Next to y equals.
The scale is 0.5.
I chose to count by half. You can count by ones if you want. It doesn't really matter what you count by. Then that's ridiculous. Because you're only going from -2 to 2. All right. Okay. All I've done is this. All right, y'all. I went to window and I put in my x min and my x max. Right, Isaac? Okay. All right. So now I'm going to hit graph. And it's going to create a graph for me. What did you do? We literally was just there. We were just there. Your image should look like this. With color, because y'all have the updated. Huh? Did you change your window? Did you follow the windows like we did? So your window says this. If you click on window, are these the values you have in? Oh. Okay, if your graph did not come up, please check your window. Pretty, please check your window. It's the user. You just hit window, then graph when your window's set. Okay, so then you're gonna hit graph. All right, I'm gonna go through the steps and then I will come around and check people who are lost. Okay, so once you're here and you want to identify your local maximum and local minimum, when I look here, I can clearly see that at some point it increases, then it decreases, then it increases, right? These values are really small to find, so how do I find them? We use what's called second trace. So to find our local max and min, we're going to press second trace. So it's the second button followed by the trace button. So notice I'm going to press second. My little arrow says, okay, you're ready. And when I go to trace, what words do you see? Oh my gosh, do you see a word that we may need? Minimum and maximum, you don't say. Okay, good job. Okay, so we're going to select whichever one we're doing. Okay, so we're going to do the minimum first.
Wait, how do you say?
Second, trace. Right down, right here. Okay, so second trace, and now I'm going to go down to the minimum. Okay, and when you go back, I call him the spider. You should have a little blinking spider on your screen. Okay, so minimum means that I need to be somewhere where I'm decreasing, then increasing, right? So right here, this would count as my spider. Do you see the spider? Okay, that's why I call it spider. So when you're, shh, please stop. When you are doing this, you have to start from the left of where it's at and work your way to the right. Just like you read a book from left to right, you're going to work your graph from left to right. So I'm going to go to the left of my graph around my minimum. And I know that this is my minimum because this is where it decreases, then it increases. Agreed? So I go to the left. You want to make sure that your Y value, we're not doing maximum right now. We're doing the minimum right now. So I hit my left down, and now I'm going to move myself to the right because it says go to the right. So I'm going to go to the right, and I'm going to, once I'm there, I'm going to click enter. And it's like, you want me to guess? You want me to tell you what's happening here? And I'm like, yes, I do want you to tell me what's happening here. And I hit enter, and it's going to do some thinking, and it's going to say, ha, I found your minimum. Okay, so I'm going to do it again. Easy killers. We're going to do it again. Take a breather. I'm going to clear what I just did. And I'm going to start the steps again. We have second trace. See where it says minimum. I press 3 for minimum. I know that my minimum is somewhere in this range. So I'm going to go to the left. Doesn't really matter how far to the left. And I press enter. Then I'm going to take my spider and go to the right. Doesn't really matter how far to the right. Just need to go to the right of it. And I press enter. And it's like, is this the interval you want me to guess on? And I'm like, yes, this is the interval I want you to guess on. And then I press enter. And it's going to do some thinking. And then it's going to tell me my minimum. So it tells me my minimum is at approximately x equals 0.707. The value is what? Value is negative 0.414. Okay, so again, all I did was do second trace and click from left to right around where I thought it would be. I don't know how else to say that. Okay, and then guess what? We're going to repeat the same thing, but this time we're going to do the maximum, right? So you're going to do the maximum. So I'm going to press clear. I'm going to repeat second trace, and I'm going to go to the maximum. I'm going to click maximum. My maximum is on the left side of my graph. So I'm going to move my spider to the left side of my graph. He's going to go to the left of where I think my maximum is. And I press enter. Then he's going to go to the right of where I think my maximum is. And I press enter. And I want it to guess. And it's going to think. And it says, here is your maximum. And that is how you find your min and max using the calculator. Huh? Yes. All we had left was say where we're increasing and decreasing.